Yeah, we're going to talk about building innovation to the limit, about how architecture influences in behavior and sustainability. A little bit about the office first. We are 80 people sitting in Copenhagen in this old listed building here. We moved in there 4 years ago. We started the office in Aarhus and moved to Copenhagen 6 years ago, and that was when I met Kasper, or anyway started a collaboration together with Kasper when he came with all his idea about the innovation unit, and we took that up, and now it's actually a big part of the office. We are 80 people, I say, and 10% of that are doing the research part. We've moved into this old listed building that we renovated ourselves, and we made this light ceiling that you can see here because we were only allowed to have very few windows in, and we wanted as much daylight-like situation as possible. And with this light ceiling, you cannot feel it if it's the day or night. It seems like day all the time, so people work late, and so it really works. And this is how it looks in a daily situation. We do a lot of models. I want everybody to work with their hands and feel the stuff in between the hands. So of course everybody works on the computer, as you can see here, but it is very important to get a lot of models. So we have 2 laser cutters that are working 7/24 all the time. We work mainly abroad, actually. 60% is outside Denmark. This is from our Indian team, where we're doing 2 high-rises right now. And we won an arena just a couple of months ago, just before summer, in the National Arena in Copenhagen. This is a model for it, where we're up against Foster, Grimshaw, Populous, and amongst others. And this is a little bit, that's from the first floor looking down, where the public relations department is sitting. This is Didi, my PA, talking together with another person from the office. And this is me. I have no office. I'm sitting in the middle of everything and walk around, like Kasper's doing the same. We think it's very important that we're all together. And as we talk about how architecture creates behavior, it's very important to practice this in the real life too. So that's what we do in the office. And we do design too, or Kasper does. This is a lamp that he designed, the star lamp. More or less for the fun of it. And now it's actually going into production. Kasper's unit, the innovation unit, is sitting on top of the office up here. And as you can say, it's really a playground for weird things up there. A lot of strange designs and a lot of strange materials. The reason why we started it was because we will not be driven by what materials there are around, but more see what do we really need here. And so that we don't invent things, but we find out of things that are around the world that nobody else might not be using, and using that in our buildings. And very much often use common sense about how to combine new materials or new software or other things. Kasper will tell more about that when he comes in. We have a lunch for all our staff every day because we would like to keep our staff in-house. So at lunch break, they're all sitting here. We feed them. And then they talk together about what is happening at the office, very much about the policy that we have, this is about knowledge sharing at the office too, which I think is highly important. And we did an exhibition 3 years ago called Mind Your Behavior, not to tell people about how to behave, but as I said, more about how architecture shapes behavior. And there we had close to 30 projects at the exhibition at the Danish Architectural Center. And we came out with this book where we talk about how all the different projects is working in that sense. A little bit of history. Here's a building we designed 20 years ago and was finished 12 years ago, I think. Took a long time to get it up. It's a music building in Amsterdam for contemporary classical music, this part here, and contemporary jazz music, this part here. And it is part of a master plan that OMA did, where they wanted the building to be the locomotive for a new area behind it. Very much in this philosophy about how a building can get people out in the area and animate an area. That was very much the idea about this building. And it has actually done that. It has been a destination in Amsterdam, and it has become a very popular building. Even as we had, as we always have in Holland, a very, very low budget for this building here. We had more or less the same budget as for an office building, and this is 25-meter high spaces. So that's why it took so long to build, because we had to really find ways to do it in a cheap way. But it works very much with a lot of events, not only in the halls, but in between the halls too. And what they wanted was a social meeting place, a social realm for the whole area, and it has become that. As you can see here, that's one of the events that was going on at the place. Of course, there's a concert halls too. This is the big of the two halls where they wanted a black box, and we did a light box with together with the light artists. We did this light arrangement that can change with the music, and actually there's a couple of composers that has designed music with the light together and made a film about it, how the walls play together with the music, and you can see music here in 3 dimensions inside that hall. But I'll start here with the learning behavior. As I said, I'll talk about different behaviors, and the first one is the learning behavior. Can a building itself aid to the education process? We believe it can, and we did this high school here, a competition that we won 10 years ago, close to 10 years ago, and has been finished for the last 5 years, where there's no classrooms. This is a big inside cityscape. The idea is that the students, this is the outside of the building, I'll talk more about the inside. The idea is that the students should interact, meet, communicate, and it should be a very open environment without classrooms. So we have 5-story high, these boomerang shapes moving around the central staircase, combining all the different floors, and then some round auditoriums with lounge areas on top. So it has more reference to a Greek village, mountain village, than it has to anything else, not so much as a building. And this is a cantina when you come into the building, and from there off you can see the whole idea about the building with the staircase coming up, combining all the different floors. And on the first floor you have a overview of the whole place. I think it's, and this is how the students work. This is how they work at home. So of course this is how they work at school too. They like to lay on the fat boys' pillows there with a little laptop. Everybody there has got a laptop. We call it the virtual high school too, because they're all virtual at the school. But the idea is that they should see each other, be inspired by each other. And actually in this school here, that is designed for 800 students, now there's 1,200 students in it. It has become the most popular high school in Denmark. This is for kids from 15 to 19 years old. And as I said, it's so important that they learn from each other. They learn maybe more from each other than they do from the teachers. And they feel at home at the place. Actually, I think the school finishes about 3 o'clock in the afternoon, but you can come there 6 or 7 o'clock in the afternoon, and there's still students in there because they see it as their place, as their playground. And we have learned a lot from that school. It creates students at the other end too. We used to say, how can we compete against India that educates as many engineers every year as the whole population of Great Britain, 60 million every year. We can only do it in a more creative way. So this is what we call creative education. The next thing I would like to talk about is social behavior. Should interaction cease when working begins? We learned a lot from the school and try to implement that in other buildings. Of course, in other ways too. This is a small saving bank in a small town called Middelfart in the center of Denmark, where this is, as I said, a saving bank. The building is, as you can see, bigger than all the surrounding buildings. It has become more than a bank. It has become a community building for the small community. There was a competition. I would say 90% of all our jobs comes out from competitions. There's a tradition that we always have to go into competition in Denmark and in Northern Europe. And the client the old bank was laying in this situation, and the client wanted us to use as much as we could of the old construction. So what we did was to build on top of the old building and make an inside landscape, open landscape again, and again with staircases. We love staircases, not only to come from one floor to the next, but as interaction areas. So all these staircases you can sit on and meet and use for other things too. But in the morning, the director, he comes in and he walks up and say hello to everybody, and everybody can see what is happening in there. They have this open environment. Then down here on the ground floor, we have a small inside plaza that is given back to the small community, where they can have concerts, Christmas trees, parties, and they've had flea markets too, a lot of other things happening even when the bank is open. And then we put, of course, a roof on the building, and the roof has the qualities that it should have. Its shading for the sun that comes here from the south and opening up to a view to the north. So there's a lot of daylight, which I think is so important in places where people have to work and be. And we like to work with elements. So this is, of course, a repetition of small elements. Actually, it was so fast to build this, to mount this roof here a lot faster than the contractors thought it would be. They thought it would take 3 weeks. It only took 3 days. So it was more a matter of getting trucks enough to transport all the elements in at the end of the day. And it became this repetition that here I think is quite interesting. And when you see it from a bridge on the other side, you can see this roof here, and as I said, here the building has a bigger scale on this distance. But when you come closer to it, down on ground level, it has the same scaling as the old buildings, which I think is very important. It is important that buildings has a context, and I think don't build anything if it doesn't add anything positive to the site. This is our mantra, and this is what we try to do with this building here too. And we tried to blend it in inside the town, blend it into the old building mass. This is actually where the bank started 100 years ago, and then it moved to this building. So we have references in the way that we work with the facade to the old woodwork on the facade, but of course in a new way. And when you come into the building, you come into this inside plaza, as I said. There's a little bookshop here and a cafe over there. And then you can have an overview of the whole inside. And the roof becomes the ceiling on the inside, and more or less a decoration of the inside as well. So it reflects what is happening outside inside, which has been important for us. And you have these different landings from where you can see from one to the other, and have, as I say, an overview about what is happening inside your workplace. And this is what happens in the weekends, small concerts, and of course Christmas trees, parties, as I said, which is important too for the building. Olof Eliasson, a famous Danish artist, made these kaleidoscopes that are 3 meters tall in the floor, reflecting the inside of the building and adding to the building in a very, very nice way, I think. Another building that has got the same kind of theme, adding to an environment, trying to connect different parts of a city, is this town hall that we just finished this summer here, actually, in Nieuwe Rijn in Holland, where it is a multifunctional building as well. It has shops here connecting to the shopping area over here, and it has got a library in the inside and a town hall function as well. And it has a little way through, so it connects a cultural area with a shopping area to the other side. And then it has got this staircase up to the wedding room, from where you can get married, and the married couple can come out and you can take the photos, and the limousine can be standing out there. So there's a little bit of poetry in it as well. And we have a roof garden that's open for everybody. So when you come in, it is a town hall. It is a public building. This building is belonging to the small society, and it should be a very open, we think, building for everybody, with a lot of daylight inside. All the functions actually wanted to be on the ground level, but of course it couldn't be because of the size of the site. So, but with this openness, that is of course inspired from our school, the library up here was satisfied, and the social functions here were satisfied, because everybody could see where they were, and they could have visual context to the surroundings too. And we placed a staircase in the center, very much for people to get exercise too, of course, but to meet. That's actually something you can see when two people walk on a staircase. They start to communicate in a different way than they do if they walk along a corridor. So this staircase has become a very important function for communicating, interaction, and for seeing what is happening in the building too, following all the different functions. So there's only one elevator here in the center for disabled people, that there should be, of course. But most of the people, they take the staircase up in the building. And daylight, as I said, is so important. This is a very deep building, but because of this openness and you can get daylight from top to bottom in the building, so you hardly need any artificial light in the daytime. And over here we have the library, here the social functions. And then they come up to the top, you have a public restaurant with an outside garden. And of course you have to have the town hall as well. And there's a glass wall here, so you can see what decisions is going to be made inside the town hall, so the population the people can follow what is happening inside their community. The next behavior I'm going to talk about is public behavior. And sometimes you're invited to build in an area where it's very, very difficult to build because it's a listed area, for example. Like this harbor here in Liverpool that's on a World Heritage Site. We were invited to a competition up against Liebeskind, Zaha Hadid, Snøhette, and others on this old docklands in the center of Liverpool. Nothing had happened in Liverpool because of a big depression for a long, long time, for 75 years or something like that. So it was a very unspoiled area. This is the area. So what we wanted to do was not so much make a building, but more a nexus connecting all the different lines, all the different paths in the area. Sort of a land art that you can come into and you can look around. This is a museum, a natural history museum about Liverpool, telling all the stories about Liverpool. It contains the stories about the Beatles, of course, that has been very important for Liverpool, and football, locomotives. They have actually 150,000 different items in there. So what we should do was more or less to do a shell that could have a lot of changing exhibitions inside. But at the same time, we wanted to create something that could connect the area and make a social realm again for the community. This is where you go when you want to learn what Liverpool is about. This is where you go to learn what is going to happen in Liverpool. So it is a place where the tourists first meet, and this is a place where the Liverpoolians always come back to see what is happening in their own society. And of course where school classes comes and whatever. It has become a very popular place. Within the first couple of months, 400,000 people came to see this building and the inside of the building. And Liverpool has 500,000 people, so that was nearly the whole population in the first 2 months that came to see the building. And we wanted to design a building that had connections back to Liverpool with big open windows and out to the River Mersey that has been the life nerve of the town. And to tell something about what used to be there. It used to be a shipyard, so it has a reference to ships as well. And it has to be respectful for the old buildings too. Here is what they call the three graces. There was the three dominating ship companies headquarters in the old days. And there was a lot of restrictions about sidelines from here to the three graces and from over here to the three graces. So we turned the building so we didn't disturb these sidelines. And then and respected the sidelines to the old building. And that ended up in a building you always see in an angle, so you never see it straight forward. You always see it in an angle, and which I think is an advantage for the building. We wanted the building, as I said, connected to the side and more as a piece of land art. So we took the promenade and sort of bended it up to become this structure. Disabled can come up this way, so this is a way to see it in a dignified way. And a big staircase that is more than a staircase, but like a grandstand for when Paul McCartney he will be playing down here, hopefully, or whatever is going to happen in this wind area in front of the building. It was a challenging task here. There was even a canal that was going underneath the building, so the building is shaped like is designed as a bridge construction too. And they wanted an iconic building too, but not crying louder out than the old building. So we wanted to make a building that was lower than the existing buildings too, and had respect from the old buildings. And this is about making a building more than a building, a connection between different areas. We did with this building here in Molde in Norway. This is a building for jazz music and a library in Molde. And this is Molde in a beautiful situation, like many of the towns in Molde, overlooking the fjord here. And we didn't get the nicest site. We actually got the worst site in location in the center of the town, and that was here in the center of the town, where there was a ditch disconnecting this part of the town with the other part of the town. So our task was to connect the two parts of the city as well, we thought. So what we did was coming up with this idea that the building should not be as much as a building, but just as much a big staircase connecting the two ends of the town as well. And they have a jazz festival every summer where there's a lot more people coming that the building can contain. So the outside of the building becomes a stage area too for this jazz music. And here's the model from the competition, and here it is how it looks when it's finished. Even that you have limited budgets or whatever, people will never think about that after it's built. So I think it's so important to build what you actually design and build what you have, the design you made from the competition. So it is very close to what we designed originally. And this is early in the morning when the jazz festival is around, and this is when the jazz festival is around. So you can see it is populated. And here you can see what I mean about the building becoming more than a building, but just as much as a connection between the two areas as well. The staircases can be used as stands and viewpoints too, from where you can look down and see what is happening outside the building. And of course, the building has a heart. It has a library, cultural functions, and a center from where a little hall where they can play music inside the building too. Human behavior. What makes people choose new paths? I think, very often a building should. This building here I'm going to tell about is an aquarium that a competition that we won in Copenhagen, and that we nearly finished building now, where we wanted to tell the stories about fish and water, because this is what it's all about, aquarium, of course. And the first 5 weeks of a 7-week competition period, we used only to find out what idea should be used for this shaping this building. I think it's very important that when we work with shapes anyway, the shapes has a connection to what is happening inside the building, of what we want to achieve, like you saw the other projects, about connecting different areas or whatever. And here it was very much about what we were going to tell the story about what's happening inside the building. And then again, this about showing new paths was about that in most aquariums, you come in one line and then you come to the sharks and you cannot come any further. Here our idea was that you can show your own path. You come into the center and then you can see, in here we have the sharks actually. If there's too many people in here, you go into the tropical forest, or you can go into the Nordic Sea or whatever. You can choose your own path. And it's more, you come in here and then you can see what is happening. So it's you yourself that is choosing your own path. And this is what this building is trying to do. And then we put it into this whirlpool shape. And actually, the advantage about this shape here is that you can add to the building forever. So it has no limitations for future extensions too. And it is next to the airport, so you actually will see it from above. So the fifth facade becomes very important, and it can draw tourists to the place just from when they're landing, seeing what is happening down there. This is the aquarium. So this will probably be, and hopefully be a popular place to go to. And we put the whole building shape here into a pool of water, so you actually walk down into the water and feel that now you're really coming into the water when you go into the building. It was a challenge to build this, and there again, GXN comes into the picture, because here we work with Grasshopper, a new program that helped us a lot to make this building within a budget that was very limited too. We had just a normal budget for this building, a budget that was more for a square building, and we had to keep the budget. So we did a lot of tests of how we could build this in a cheap way, and what patterns we should use to clad the building too. And we ended up in this pattern here actually, with aluminum shingles on the outside that we could bend in a way to follow this amorph shape. Again, I think as I said, I think it's important that we build actually what we design from the competition. And we wanted this feeling when you come into the building that you are underwater. So we created a light feature here that illustrates now you're underwater. We work together with a light artist and a sound artist, so we have both sound, underwater sounds, and underwater lighting, staging the whole situation with what of course is the important thing. It is the fish in here, so you get a total experience when you go into the building. When you see it from ground level, you might think this is a whale more than a whirlpool, but I think that's all right. It has something to do with water creatures, and that was what our aim was. And this is a couple of months ago when we're building it, and it's actually being built in the shapes that we wanted to. Nothing has been straightened out. Yeah, and then come to the shift between my lecture and Kasper's lecture. Kasper will now talk about material behavior, as we say, ecological design research. So Kasper, you should have this one here.
Oh yeah. Oh, I'm mic'd up. A lot too louder. Okay. And this for the archive. All right. Thank you for having me here. Kim has been so lucky to be in here a few times, but this is my first time today, so I'm actually been really excited to come and share our work and thoughts with you. I'm going to talk about materials, so let's just start right away. I mean, we work a lot with materials in many directions and also with many approaches, and this is one that is kind of a untraditional way to talk about, for example, mushrooms. As you might know, this is something that we're brought up with keeping out of our buildings. So to me, I started a collaboration with a upstate New York-based company that actually uses the mushrooms, the roots of the mushroom, to bind things together. So seeing mushrooms as a potential building material that allows for growing instead of producing materials. It opens up for talking about grown materials that is binding by these husks, seed husks, and agricultural leftover materials, creating materials that when growing can take upon any shape, and also in the design of the materials they can be soft, they can be hard, they can be acoustical, they can be structural, and also have some kind of weird aesthetics. So just saying that with that approach we can talk about growing sustainable materials that requires no energy in the making, and that has a huge form potential. This is materials that currently we are working with, doing some design experiments, and secondly integrating that into building components. So GXN in relationship to 3XN is our innovation unit. As said, we started out in 2007. Actually, I started out in 2007 as a one-person unit, really just working for 2 years trying to connect to a lot of different knowledge fields, a lot of different industries, a lot of academia and universities, and then production facilities and factories. And we do this innovation approach due to the fact that, honestly, as an architect, you spend a lot of time with yourself, sitting in front of your computer. 90% of the time you're doing this design development, sketching, etc. Then you talk to your neighbor and to the team that are likely also to be architects. So we want to kind of open up the space and the diversity of collaborations. So it's important for us to have a kind of an active network of, for example, now we are working with biologists and chemists and artists, physicists, etc. So also said that it's more than myself now. Now we are 10 persons, so 8 architects and an engineer and a psychologist. So having this kind of a network-based platform where we actually can engage and include these external competences is kind of the basis for our work. A good example on innovation in 3XN and GXN is this project. It's a headquarter for an attorney company. It's situated in Copenhagen. As you see, and also that Kim's shown, we do a lot of work with facades and the building skin, working with a three-dimensional pattern. This is a good example on how this creates some kind of inner spaces, some inner qualities. Each of the attorneys have their own bay window viewing towards the harbor front of Copenhagen. And at the same time, seeing from south, it's a very closed building. So we also use this movement to create self-shading, like use the building geometry to actually prevent overheating of the building, which is the biggest problem we have, even though it's in a Nordic region. We really want the sun to keep out of the building. And from north, you see how it opens up and actually becomes a very transparent building. This was examined in many ways structurally. We were looking at doing a steel structure that would become very complex and very heavy. And instead we chose to go into kind of another structural material. So learning from windmills. In Denmark, windmills is a huge industry, and something that we wanted to include in the way we put these units together. So having this kind of structural sandwich composite, which you might know from windmills or surfboards, we actually created a very lightweight building, and also we were able to mass produce it. We simplified the geometry down to being 2 components. And in that way, we were able to introduce this kind of complex shape in a rational economy, and letting this be a combination of inner qualities, of sustainable features in energy saving, and also resulting in a certain kind of aesthetics that we really like when the shape and the variety of the geometry actually gives something back to the persons living there, and also to the sustainable performance of the building. And to me, I mean, I'd like to zoom in a bit, talk about these materials. So I'm very fascinated about micro design, and often a design that you don't see. We normally often refer to design as objects or something visual, as chairs or buildings. To me, I think the world of science, material science, is extremely interesting. It's also accelerating. The knowledge we have on biology and chemistry and physics is doubling every 10 months. It's actually intensely the rate of development is following that of the development of computer force. So we today can talk about materials in another way. We tried to express that earlier this year on a material exhibition called Material World. I'd like to hand the kind of the catalog on to you, so you can distribute it afterwards. The great thing about new materials and innovations within known materials is that you get often quite surprised. And it's not just a matter of talking about defined categories like stone, glass, metal, etc. It's talking about behavior, material behavior, and what do I want my material to perform. And often it's also, it's not just like solid materials, it's very much about surface coatings and a way to design materials to be able to enter other use periods, etc. These examples is just 2 talking about some from the exhibition. For example, this bendy wood. I mean, it's actually wood that you can start to bend, and you can start to make knots with. So you can actually just compress the fibers in the wood when heating up the wood and in a moistured climate. The wood is compressed, and you actually have a very, very flexible material. And another one is, I didn't bring that one. Well, anyways, you'll get 100 to view upon later. I'd like to talk about this, for example. That was not on the exhibition. That's spider silk. And in nature, that's the most strong material you can find. It can be up to 50 times as strong as steel. That is something that you really want to get your hands off in, but it's hard to mass produce. So today it's not possible due to kind of the aggressive nature of spiders. So there's actually some Canadian scientists that has isolated the protein of spider silk and gene manipulated that into mountain goats. So actually here there's some cutting edge in Canada where you're milking spider silk of mountain goats. And I'm actually really jealous because it's not legal in Europe. So maybe that's on my sightseeing on Saturday, find that goat. Well, anyways, another material is carbon nanotube. That's also kind of the tomorrow's super material. And that's nanotechnology bottom up, where you see the very fine tubes on the upper left is actually where you, through science, are able to structure atoms one by one in these tubular structures, creating insanely strong materials that are 100 times as strong as steel. And today it's only something you can grow in lengths of half an inch. But yet that's something that you can use as a mixer into concrete, into composites, and actually today already you can start to work with new super strong materials that allows for new structures and spaces and minimal use of material. Also, it's superconductive, so In Germany, you also can buy paint with carbon nanotubes, so you can use it as heaters, just that you can apply it directly on surfaces. So some of these materials are for tomorrow, but a lot of them are for today as well. And a good example on where we are using that is in this project that we won a competition in the heart of Berlin, right next to the parliament. It's called the Cube. This is actually a quite massive structure, only kind of eroded with these atriums around the central core, also framing the view of the city. To get as much light in as possible in this glass building, we wanted to work with transparent insulation. So here you have aerogel. It's actually an old school material from, I think it's 32. Recently it's been developed in the manufacturing way, so you can produce it with a lot lower temperature and also giving a lot lower price. So you can actually start to use this in architectural applications. Well, aerogel is highly insulating. It's the world's best insulating material. At the same time, it's also the world's most lightweight material. So it consists of 99.8% air. And that's also the kind of a secret to the highly insulating quality. So what you see up here is it's kind of the molecular structure that's hollow. And that's actually what makes insulation. That is having air standing still. That's what you find in mineral stone wool, in all these kind of fiber mixes. But in the aerogel, it's inside the material, so it's embedded in the kind of molecular structure. Outside the glass, we work with a self-cleaning glass. It's not like 100% self-cleaning, but it dramatically lowers maintenance requirements. And we chose a coating on the glass that also works as an air purifying coating. That means that it has a chemical process that starts when activated by the sun with UV lights. And it starts to break down pollution from the environment, the NOx particles. And doing that on the whole building, we actually, besides having lower maintenance, we are giving something back to the city, supplying the close environment to the building with clean air equivalent to what could be a small forest. Inside, we try to avoid mechanical cooling and using self-phase changing material is actually helping on that a great deal. So that's some small grains, like a tenth the size of a sand grain, that you can mix into, for example, the plaster that we use in the ceilings. So these small grains are in plastic pockets, like small polymer pockets, in which you have a paraffin that is able to change its phase at 21 degrees Celsius, being more or less the temperature we have here now. That means that the material can actually absorb all the heat that excess that specific temperature. And in that way, you don't need to add mechanical cooling. When the temperature drops, the material releases the heat as well. And in that way, it's kind of a natural solution for having a specific indoor temperature. And the great thing about the paraffin is that you can actually design that to when it should shift phase. So if you want another level, that's also possible. So I'd like to go through 5 different design strategies that we work with in GXN. First is green design, and I mean it's kind of talking a lot about how to use materials in ways so you can start talking about not producing waste. Because I think that's funny to talk a lot about minimizing and talking about waste in general. I mean that's something that's a man-made word. It doesn't exist in nature. So I think that's where our kind of focus on the biomimicry comes in. We really want to see nature's ecosystems and see how we in buildings can build with materials where all the materials can have future purposes for other usage, either by entering a kind of industrial circulation or also the biological decomposing, etc. So I think in buildings and buildings like the one I'm going to talk about, we really would like to try and make positive outputs instead of just minimizing waste or minimizing energy. We'd like to actually produce energy. We'd like to produce oxygen. We'd like to have buildings that are built in materials that are healthy, supporting great indoor climate, and that can be recyclable. This is a high school. And the purpose of the high school is aquaculture. So the client is asking us, in this case, actually to integrate as many kind of living materials, you could say, living green solutions. And we're working now for almost 2 years by mapping out the wild plant species of the Nordic region in Scandinavia. And now we have ability to produce more than 500 different red-listed species and species that you couldn't actually access before. In that way, we want to use the building to extend the natural life and the natural biological context into the building through working with green walls and green roofs. Want to actually enhance the biodiversity and biomass. Inside, we are working with more sophisticated manufacturing methods like hydroponic and aeroponics, also classical plant beds. But just to demonstrate that there are many ways actually to talk about food production in central cities. So the building would produce food, obviously, for the students in there, but also combined with a whole food shop, sell to the neighbor and the local community. For example, strawberries are very efficient in doing that. Actually, you can get an accelerated growth of factor 10. So every month you will be able to have your strawberries in the strawberry gardens in the building. Also in the facade, we are using algae, working with an engineering company called Arab to actually use algae, microalgae in the windows. So the window panes are filled with water in which we kind of have it supplied with oxygen. So you have this beautiful kind of pattern of oxygen coming up through the window, and during the day as the sun comes in, you actually start to grow the algae, and also you start to grow the solar shading during the day. And that actually gives us a chance to take all the energy out of the water, but also the energy from the biomass of the algae. So this is a building that's a mix of obviously educational program, but also dormitories and elderly living. So it's really kind of a social generator in that area of Stockholm in Sweden. Just seeing how the building also works as a public accessible park and also a bridge to the behind-laying forest. We work a lot with informed design, and that's design in the very, very early phases of the time you work with a building. That can take many years, but it's actually the first 10% that you make almost 90% of the decisions of like the orientation and the volume and the geometry and the floor slab design, balconies, etc. And that's where you have the most or the biggest impact and chance to actually work with how the building is performing environmentally. So we're developing these softwares that can help us in the first day and the first week, and not wait until the model and the project is developed far enough to use the current available softwares. And that just gives us some ideas. This is a project in India we are currently developing a tower scheme for. And it just gives us instant feedback on which way to bend it or twist it or sculpt it. That gives best daylight performance at the same time also the lowest energy performance in incoming energy. So we work obviously with this on volume-based and context-based examinations, but also on the very kind of local solar shading and balconies. We're also informing the later phases in the projects at the office. This is, for example, a project that's under construction. It's a high-rise scheme again in Aarhus in Denmark. And here we are like mapping out all the components and having them parametrically able to actually reconfigure this even though we are in construction phase. So we can actually tune this into the economy of the project and also to kind of fine-tune it with the local parts of the balconies and spaces very close to the apartments, etc. We work with behavior design as a very special focus, and as you heard, Kim went through all our recent buildings, kind of saying how important it is for us to know how architecture is shaping behavior, or at least supporting learning environments or educational environments. So in that way, we have a kind of a post focus on our buildings. So after we did build this bank, as Kim talked about, we really wanted to see, okay, do the environment with the staircase works? How about all the kind of terraces that creates this democratic workspace and still yet give you an identity of your local environment? And are all of these features actually functioning as we planned them to? So we are post-evaluating the buildings, going out and taking those learnings and implementing them in future projects, etc. For example, the high school is exactly the same. All this kind of compressed program that allows us to have this spacious school that allows for kind of a central stair where you have the daily informal meetings with all the small points of hanging out, organizing yourself, finding your own places to seek education. I mean, that's something that we are constantly evaluating and implementing those results in future buildings. We work a lot with technology, also with, for example, this is a solar mast where we are, or did work, it's 2 years ago now, but with the latest solar cells, latest LED technology, how the prism could be shaped to direct the light in a way so the lamppost actually could generate more energy than it consumed, and in that way actually give energy back to the city grid. Another project where we basically is working with, I think it's the world's biggest facade contractor in unitized facade panels. It's called Permistelisa. We take their kind of core business, which is aluminum facade systems, and are working with glass fiber as a material and as a material technology. So glass fiber is can be worked with in the same way as aluminum, but just offers a set of a whole other possibilities. So it's very low in thermal conductivity, so you don't have the cold bridges. It's potentially translucent, so you're actually able to work with facade systems where light can come through. Well, there's no corrosion to it. It's also quite lightweight. And combining it with the aerogel I talked about earlier, we're getting a facade system that has half the depth with double the performance. So this is a project that's also being undertaken a lot of development phases and will be on market next year. So the last strategy I'd like to talk about is experimental design. And to us it's important, being an innovation unit, to kind of innovate ourselves. So we take in projects where we don't necessarily have the answer, and also where we can test out things that we haven't tried before. And this is a good example of a sculpture we did, where there was a museum addressing us saying, well, we're doing an exhibition on sustainable architecture for the future. Could you just try and state what's possible with natural, biological materials, and at the same time also intelligent materials? So we said, yes, we would like to do three things. We'd like to make sustainable materials that is not just like plain or boring, but actually like rich in forms and exciting. We'd like to make materials that can be recycled 100%. I would like to make materials that is actually in a dialogue with their surroundings, that is harvesting energy, and instead of having static buildings, we'd like to have dynamic buildings. So Kim and I, we wanted to like talk about this kind of loop of energy and loop of materials. So working with this kind of Möbius geometry for quite a few lunch breaks, and came up with this geometry, kind of eternity movement, where we built up the solid structure in natural materials, and used that as a kind of a test bed for materials such as a phase changing I talked about, with able to accumulate a lot of heat and release it later. Talking about self-cleaning surface materials, air purifying materials. We used solar cells that are bendable to follow the shape of the sculpture. In the lower parts, we also embedded some small piezoelectric ceramics, and that's materials that when you apply force to them, they convert that force into electricity. So we also had some LEDs embedded in the structure to kind of show how the relationship between the kids running on the sculpture, converting it into energy. So doing that was new to us. It was new to many of the 20 companies that got engaged into the process. We went to Paris, where there's the biggest composite fair worldwide, once a year, and we're looking for a substitute for glass fiber and carbon fiber. So we were looking at natural fibers and natural binders. Working with some super intelligent but also quite challenged engineers and manufacturers called Stage 1 from the UK. They also did the Chanel Pavilion by Zaha Hadid. So we chose them because they had a great experience of talking about natural composites. But then again, they got things they haven't had hands on before, working with the cork as a core material, and the flax as the fibers, and then the soybean oil and cornstarch as the binder for the structure. So that was new, and we needed to get to know how to work with the materials, and then they called me 2 or 3 weeks, I think maybe 3 weeks before the opening, and just said like, you need to come over. And I literally just like went on a plane and came up to see this, and it looked horrible. I mean, it was just like not curing right. It was bulky. It was everything we didn't want it to be, because we would like to show that you actually are able to work with dynamic shapes and strong, stiff, aesthetic surface solutions. So I convinced them to work day and night with 3 shifts. A lot of effort been put into it on their behalf. But also being said, I mean, we only had 3 months to come up with the idea and find all the collaboration partners, to do the fundraising, and to get to know these materials. So that's a sample before we fly to the museum. And that's not very sustainable, but I mean, we're making a point of doing things that hadn't been done before. And in that way afterwards, we realized that the material itself the biocomposite was actually something we invented while being busy, just keeping the deadline. And doing that with combining the cork and the flax fibers and the soybean oil and the cornstarch actually got a lot of attention in the world of composites. That's not normally the architectural world. So Kim and I next year we flew back to Paris and got an innovation award to actually being able to give something back to an industry that we learn from most of the time. So we actually we're very proud to be in a company of Boeing and Lamborghini and others that are working with these natural composites as well. And today it's still standing there as an example on how new materials can be applied, and also how kids can generate energy, how actually the sun can start to purify the air around the sculpture. And in that way, it also opened the door for us to further engagement with biocomposites. So currently we're working with 15 other companies on a 3 years development program where we are taking the learnings from this project and actually going commercial with a whole new scheme for building skins and interior design in biocomposites. So I think that's kind of a brief introduction to the different design strategies and who we are, and how innovation and practice is running parallel in 3XN and GXN. Yeah, thank you.